Hi, Matthew. We are on page 24 in the lesson notes, so go ahead and please take out your notes so that you can attach these notes to the Edpuzzle assignment. So 7.1e lesson is building off of linear and nonlinear functions. It says complete the table values and sketch a graph of the given function. In the tables, round to the nearest tenth when needed. State whether or not the given function is linear and justify your reasoning. So for the first one, all we're getting is y equals 6. So this is kind of a throwback to module 3 and 4. If x is negative 2, it doesn't matter really what x is equal to. Y is going to be 6 every single time. And then you have some points to plot. So let's say this is about negative 2, 6, negative 1, 6, 0, 6, 1, 6, and 2, 6. Obviously, these graphs are sketches, but that's going to go ahead and draw just a horizontal line right there with 0 slope. It says, is this a linear function or not? Explain why or why not. So would this be linear and would this be a function? So the first thing we have to think about is, does this form a line? So is it linear? And then is it a function? For every input, how many outputs are there? One or more. So I said, yes, this is a line. And for every input, there's only one output. Even though that's the same, it passes the vertical line test. So I could draw a vertical line anywhere along here and it would be a function. So this next one is y equals the absolute value of x. So whenever you see something like that, this is called absolute value. And no matter what you plug in there, it's going to be positive. So if x is equal to negative 2, the absolute value of negative 2 is positive 2. The absolute value of negative 1 is positive 1. The absolute value of 0 is 0. And then obviously if you plug something positive in there, it's still going to be positive. It doesn't change into negative. So this would just be 1 and 2. So now I can go ahead and plot this. I'm just going to start at 0, 0. Then let's just sketch 1, 1, 2, 2, negative 1, 1, negative 2, 2. And this is going to form a V like so. If you guys aren't sure how your graph will look, you can also use Desmos graphing and actually type this into Desmos graphing so that the graph will form for you. It says, is this a linear function? Explain why or why not. Well, a linear function has to add the same thing every time. Here, we added 0 each time. That's okay. Here, I'm going to subtract 1. I'm going to subtract 1, but then I'm going to add 1, and then I'm going to add 1. That is going to be a function, but it's not a linear function. So I'm going to say function, but not a linear function. And I can say because there is not a constant first difference. So remember when we did that in class, we would call this the first difference. So there's not a constant first difference here. Okay, moving on to y equals x squared. So go ahead and fill out the table for y equals x squared, and then we'll graph. Okay, so your table should be 4, 1, 0, 1, and 4. Remember, when you square a negative number, it becomes positive. So if I'm going to sketch this, I'm going to say negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. This time, it's not an absolute value function. So it's not going to look like a V anymore. It's actually going to look like that U shape that we saw in class last time. We call this a parabola. And we'll kind of get more into this later, but anytime that you have something that's squared like that, we call this quadratic. And the shape that it's going to form is a parabola. says, is this a linear function? Explain why or why not. So I could go ahead and draw any vertical line here, and it would pass through this. So it is a function, but it is not linear because the first difference is not the same. And you can see that because if I go from 4 to 1, I go down 3. If I go from 1 to 0, I go down 1. 0 to 1, up 1. 1 to 4, up 3. And you might notice that the second difference is the same. So I would add 2, I would add 2, I would add 2. When the second difference is the same, you know you're going to have a quadratic function, and you know that in your equation, you're going to have an x squared. Next one is y equals the square root of x. So go ahead and fill out the table again, and then we'll graph. And this is an exception where you can use a calculator to graph this. Normally, we're used to not using a calculator for square roots, but you can actually plug this into your calculator now. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is 1.4. Square root of 3 is 1.7. Square root of 4 is 2. So you can see we have a graph that looks kind of like this. Okay, that's a square root graph. And this obviously does not form a straight line, so this is not a linear function. We can say this is still a function, but it's not linear. All right, number 5, y equals 2 to the power of x. So again, go ahead and fill out your table, 2 to the power of x, and check that your table is correct. So anything to the power of 0 is 1. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 2 times 2 times 2, so 8. And 2 to the power of 4 is 16. So when we graph this, I'm going to start at 0, 1. Then I'm going to go to 1, 2, 3, 2, 4, 3, 8. And we could actually go into the negatives. If we were to say 2 to the power of negative 1, that would be 1 over 2 to the power of 1, or half. Remember, a negative exponent just moves that to the bottom. So if it was negative 1, it would be half. If it was negative 2, it would be 1/4, and so forth. So this is actually never going to touch that x-axis. It's going to look kind of something like that. And it says, is this a linear function? Explain why or why not. It's not linear again, but it is a function. And if we're looking at the graph, obviously this doesn't form a straight line, but in our table, I add 1 here, I add 2 here, I add 4 here, I add 8 here. There's no constant first difference. So number 6 is just the recap. Examine the equations of nonlinear functions. What do you notice? Well, we only had one linear function here, and that was the first one. So what do we notice about all of the others? Why are they nonlinear? The big idea here is that there's not a constant first difference. The other thing that I want to point out is that y equals x squared and y equals the absolute value of x both have symmetry over the y-axis. So symmetry means like it's a mirror, or you could reflect it over the y-axis, and that's number 2 and number 3. So this one and this one, you can see there is symmetry across the y-axis there. So quickly recapping before the next page, if a function is linear, it needs to have a constant first difference. So this was the only one where we had a constant first difference. It happened to be 0. If I'm adding the same thing every time for every x that I'm increasing, then it's going to form a line. So I want you to go ahead and try number 7 and let me know which of these would be linear functions. So the first thing I did is find the first difference for each of these. But another important thing is to look at our inputs. So and make sure that if I'm adding the same thing each time, I need to also be adding the same thing on this time. That means the slope would be the same. So for this, I go 0, 1, 2, 3, and I increase by the same first difference. This is going to form a line. I could even write the equation of the line. This is going to be y equals 5x minus 5. Remember, we start with the e, which is stage 0. This one, I go 0, 1, 2, 3, but I go plus 4 plus 8 plus 16. That's not going to be a linear function. This one, it doesn't go 1, 2, 3, 4, but I do add 0.2, 0.2, 0.2, and I also add 0.2, 0.2, 0.2. So this is going to be a linear function as well. For this one, I have 10, 30, 50, 70, so I'm adding 20 each time, but on this side, I am subtracting 20, and I actually did this wrong. This is actually a positive 80. So that is not subtracting 20. That is not a linear function. For this one, I add 0.1, 0.1, 0.1, and I add 1 each time. This is going to be a linear function. For this one, I go up 2, up 6, up 4, but I'm adding the same thing each time on the left. That one does not work because if I go up 2 and I add 2, when I go up 3, I should add something different. That's not going to form a line when I actually plot those points. For this one, I have 5, 5, 5, 5. So right away, we should know this is not a function because for x equals 5, I'm going to have a whole bunch of points. So for each input, there could be more than one output. Remember, I could plot 5 and I could be like, oh, 5 is negative 10 or negative 5. We don't want that for a function. For this one, I go up 4, up 4, up 4. So I should be adding the same thing each time. And I'm actually subtracting negative 1, negative 1, negative 1. So this one is also a linear function. All right, number 8, consider the perimeter of a square as a function of the side length. So perimeter as a function of the side length. That means that the perimeter depends on the side length. So my dependent is the perimeter of the square, and my side length of the square is my independent variable. So if we have a side length of 1, remember, just a reminder, if we draw a square, our perimeter is, let's say our side length is x. Our perimeter is x plus x plus x plus x, or 4 times x. So our side length of 1, if my side length is 1, it's 1 plus 1 plus 1 plus 1, my perimeter is 4. If my side length is 2, it's 2 plus 2 plus 2 plus 2, or 2 times 4, 8, 3 would be 12, 4 would be 16, and 5 would be 20. Is this going to be a linear function or not? If you answered yes, congratulations. We have a linear function because we're going up by 1 each time. Our first difference, we are adding 4 each time. So we have a constant first difference there, or a slope that I'm going to add 4 for every one I go over, which means that's going to form a line. When I graph, it's 1, 4, 2, 8. And again, I could just go up 4 over 1, up 4 over 1, up 4 over 1. That's what's actually going to form my line. So write an equation to model the perimeter P as a function of the side length. So go ahead and write the equation. How do I get from S or X to my perimeter? This is just going to be perimeter equals 4 times my side length. Every single time I'm multiplying my side length times 4 to get to my perimeter. What does the point 10, 40 represent in this context? So when it says in this context, it means in the context of the square. So 10, 40, well, because my perimeter was my dependent, it means that my dependent is my y value and my independent is my x. So this would be my side length and my y value would be my perimeter. So you could say with a side length of 10, my perimeter is 40. We already answered this question, is the function linear? But now it's time to explain why is this linear from a graph, table of values, and equation. The hint here is if it says, is this function linear, and it asks graph, table of values, equation, it's a function, it's a linear function for every single one. You're not going to say, yes, it's a linear function based on the graph, but not the table of values. It's going to be a linear function for every single one. So for the graph, it's a linear function because it's a line and there's a constant rate of change. In the table, we can look at the first difference and say it's a linear function because the first difference is the same for each of these. And then in our equation, if we're looking at our equation, this is in slope-intercept form. So we're going to say, yes, this is in y equals mx plus b form or slope-intercept form. And our last question here, is this relationship proportional? Explain why or why not. You should be able to tell this from the graph or from the equation. Is this relation proportional? You should also be able to tell it from the table of values at this point. So you could say something like, yes, this passes to the origin on the graph, or if the equation only uses multiplication and there's nothing being added or subtracted, we know this is proportional. Okay, on number 9, consider the area of a square as a function of the side length of a square. Draw pictures to represent the first 4 stages of these squares. The first 2 have been drawn for you. So go ahead and try and draw stage 3 and stage 4. With a side length of 1, the area would be 1. Side length of 2, area would be 4. Try drawing stage 3 and stage 4, so pause now. So your square should look like this. With a side length of 3, your area is going to be 9, and with a side length of 4, your area is going to be 16. So we can go ahead and complete our table. Side length 1, my area was 1. Side length 2, my area was 4. Side length 3, area was 9. Side length 4, my area is 16. And then we can see the side length of 5, my area would be 25. I want you to go ahead and try and write the equation now. If you're not sure how to write that equation in Edpuzzle, I want you to just describe what the equation would be. Okay, so our equation for this, if our area is A and our side length is S, to find the area, we're going to do the side length squared every single time. So now we can go ahead and graph 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. So you can probably already tell from the graph and table of values whether this is a linear function or not, as well as the equation. It says, would this graph pass through the point 864? Justify your answer. Well, if it's 864, I could plug in 8 to S, and 8 squared would equal 64. So this satisfies the equation. What does the point 864 represent in this context? Well, 8 was my side length, and 64 was the area. So for a square with a side length of 8, my area will be 64. List 3 more ordered pairs that this graph would pass through. Well, if you kept going, you could do 7. 7 squared would be 49. You could do 9. 9 squared would be 81. You could do 10. 10 squared would be 100. And then, is this function linear? Explain using the graph, table of values, and equation. I want you guys to go ahead and answer that on your own. So your explanation should look something like this. For the graph, this is not going to form a line. It's curved. For the table of values, the first difference is not the same. From 1 to 4, I add 3. From 4 to 9, I add 5. From 9 to 16, I add 7. Those are different numbers. In the equation, this is not in slope-intercept form, but it is important to remember that when you have something where it's squared, this is going to be a quadratic function. That's it. Please make sure you upload your notes to the assignment in Google Classroom. It's okay if it looks turned in. You can just go ahead and upload them after that.